In this lesson, we're going to be talking about linear reflections. By the end of this lesson, you should be able to reflect lines across the x and the y axis, be able to come up with the new equation, and describe the type of reflection that is occurring. Linear reflections are when a line flips across another line. That line could be the x or the y axis, and for our purposes, we're going to focus on the x and the y axis. When we reflect, it does not change the steepness of the line, but it does change the direction. So what it means is that the number value, the numerical value of our slope will be the same, but it will be the opposite. So if we had positive 2 for our slope, when we reflect it, we're going to have a slope of negative 2. So the number will stay the same, but the direction or the sign will change. When we reflect, we're reflecting either across the y-axis, and to know that we're reflecting across the y-axis, the direction that we're given is f of negative x. Notice that the negative is on the inside of the f of x part. This tells us to reflect across the y-axis. When we reflect across the y-axis, you're going to notice that the y-intercept is going to remain the same. And again, the slope when we reflect is going to be the opposite. When we reflect across the x-axis, to know that we're reflecting across the x-axis, the rule that they've given us is negative f of x. Notice that the negative is on the outside this time. This lets us know that we're reflecting across the x-axis. When we reflect across the x-axis, what you're going to notice is that the x-intercept is the same, but the slope is going to be the opposite. So the biggest thing here is that when we're reflecting across the y-intercept will stay the same and we'll have opposite slopes. But when we're reflecting across the x, it's the x-intercept that remains the same while we have opposite slopes. Let's look at a couple examples. So let's look at our parent graph, f of x equals x. So remember that when we're looking at our parent graph is f of x equals x. So this is what our parent graph is going to look like. Goes to the origin, has a slope of 1. When we're reflecting, okay, let's say reflecting here, which this is across the x-axis. So remember, outside is across the x. And when we're reflecting across the x-axis, the x-intercept is what's going to stay the same. So let's talk about the x and y-intercepts from the graph that we currently have. Move this over here. So our x-intercept is over here. All right. So our y-intercept is at 0, 0. And our x-intercept is at 0, 0. So our x and our y-intercept are the same point. And so what you're going to notice is that when I reflect across the x-axis, remember the x-intercept stays the same. So if my x-intercept was 0, 0, my x-intercept for this one is also going to still be 0, 0. And then our slope is the opposite. So our slope was positive 1. Now our slope is going to be negative 1. So I'm going to have my line reflecting over the x-axis and has a slope of negative 1. So same y-intercept, same x-intercept, opposite slope. So this is what our line is going to look like when we reflect across the x-axis. Notice that the y-intercept is also 0, 0 in this case. And so our x and y-intercepts didn't change. When we look at h of x, this is a reflection across the y-axis because the negative is on the inside. So reflection across the y-axis because the negative is on the inside. When we reflect across the y, remember the y-intercept is what stays the same. So that means we're going to have our y-intercept, which is right here. Again, the slope is the opposite, so the slope is still going to be negative 1. So what you notice, if you haven't already picked up on it, is that from our parent graph, if we're reflecting across the x or across the y, it's going to end up in the same place. So this is only going to be true for our parent graph. And the reason being is because the x and the y-intercept are the same point. When we're talking about different graphs, though, this is not always going to be the case. So let's take a look at the function 2x plus 2. If we graph this, if we graph 2x plus 2, Okay, notice that starting at 2 has a slope of 2. If we graph this one and we translate it, it's gonna look a little different when we're reflecting across the y and when we are reflecting across the x. So if we're reflecting across the y, or the x, let's start with the x because that's the first one. So if we look at g of x, if we're reflecting across the x-axis, notice that the x-intercept is going to be what's going to stay the same. So let's take a look at what our x and y-intercepts are from our current graph. So the y-intercept for this particular graph right now is 0, 2. The x-intercept is -1 and 0. And so now let's reflect it. So remember, reflecting across the x-intercept is what stays the same. Across the x stays the same. So there's my x-intercept. And the slope is going to be the opposite. So here my slope is 2. When I reflect it, the slope is going to be the opposite of that, so it's going to be -2. So this tells me to go down 2 and right 1, or up and to the left. It's going to be that negative slope. And so when I reflect it, this is what my line is going to look like. It reflected across the x-axis. And so when it reflected across the x-axis, this is what we got. All right? If we look at the second one, though, if we look at across the y-axis, we want to look at a couple things. Okay? First, let me fill in my x and y-intercepts. So my y-intercept here was 0, -2. Notice that my y-intercept was also the opposite. So it's not just the slope that'll be the opposite, but the y-intercept will also be the opposite when we reflect across the x. The x-intercept, those stay the same. So my x-intercept is still -1, 0. Okay, now if we're looking at graph number 2, if we're looking at the reflection across the y-axis, remember that the y-intercept is what's going to stay the same. So my y-intercept is going to be 0, 2. So that's where we're going to start our point. The slope is still the opposite, so the slope is still going to be -2. So it tells me to go down and to the right, or up and to the left. And here is my reflection across the y-axis. So again, I'm reflecting across the y. This is what my line's going to look. The blue line is what my line's going to look like. Okay, it's important for us to kind of see or recognize the difference here, because if we don't get the reflection correct, if I don't know what it looks like to reflect across the x-axis and what it looks like to reflect across the y-axis, what we'll end up with is two very different lines, and so we don't want that to be the case. Okay, if we're looking at just like with translations, we want to make sure that we can reflect when we have the equation and when we don't have the equation. So if we're looking at this one, we want to look at the y-intercept of our graph. So the y-intercept of this graph is 0 and 3. To find the x-intercept from the equation, remember that anytime we want to find the x-intercept, we make the y 0 and we solve for x. So if we make f of x, which is y, if we make that part 0, and then we solve for x, what we'll get is we'll start off with 0 equals x plus 3. When we subtract the 3 from both sides, what we'll see is that our x-intercept is -3, 0. Okay, this is helpful for us. If we're looking at g of x equals to -f of x, this is a reflection across the x-axis, so across the x, so a flip over the x. This tells me that the x-intercept is going to stay the same, so I'm still going to have an x-intercept of -3, 0. The y-intercept is going to change, and if you remember from our observation before, that if the x-intercept is the one that's staying the same, then the y-intercept, when it reflects, will be the opposite. So instead of 0, 3, it will become 0, -3. What we want to be able to do here is we want to be able to write the equation of our line given the rule. So in this first rule, we have in A, we have negative f of x. So what this is telling us is it says, take f of x and make it and multiply everything by negative 1. So what this is really saying is negative 1 times f of x. So it says take whatever f of x was. So in this case, f of x was x plus 3, and multiply it by negative 1. And so when we do that, what we end up with is negative x minus 3. So anytime the negative is on the outside, what that's telling us to do is it says take the function of x and multiply everything by negative 1. And so what we'll end up with is negative x minus 3. And so g of x in this new equation is equal to negative x minus 3. If we look at b, so taking a look at b, we have f of x is equal to 3x plus 1. And so what we have is h of x is equal to f of negative x. So what we want to do first is we want to figure out what our x and y-intercepts are. So our y-intercept is 0, 1. Remember, to find the x-intercept, we make that y 0, and we solve for it. So if I solve, I would start by subtracting 1 and then dividing by 3. And so what we would end up finding out is that the x-intercept is negative 1/3 and 0. Okay, this one is a reflection or a flip across the y-axis. And so when we flip across the y, when we reflect across the y, remember that it is the y-intercept that stays the same. So 0, 1. And it is the x-intercept that's going to change and become the opposite. So instead of negative 1/3, 0, now we have positive 1/3, 0. And then we want to make sure that we are, that we can find the new equation without using the graph. So we have f of negative x. Remember that any time that the change is happening inside, what it's wanting us to do is it's wanting us to evaluate f of x for whatever's inside that parentheses. So what f of negative x is saying is it says take f of x and evaluate it for negative x. So anywhere in my original equation where I had an x, we're now going to replace it with negative x. So instead of 3 times x, now we're going to have 3 times negative x. And so what we'll see here is that when we simplify it, we'll have negative 3x plus 1. So h of x is equal to negative 3x plus 1. And then you can check it. So you can check this using a graphing calculator. If you graph your original line and your translated line, what you should see is a line that, or your reflected line, you should see a line that reflected over the y-axis where the y-intercepts are in the same spot, or a line that reflected over the x-axis where the x-intercepts are in the same spot. Okay, before watching the next video, what I would like for you to consider is how we know the difference between reflecting across the x-axis versus reflecting across the y-axis. As usual, please subscribe to the channel so that you get updates as new videos are released. And thank you for watching.